Hi, my name is Bruce. This is now the third in the series of the core cutter. I've now finished putting together all the pins. By the way, I'm doing an experiment holding the GoPro by hand. I've now made up all the retention for the pins and the pin retentions by using fishing line and locking that up and putting it through a cotter pin here in the side. So that allows for these pins and when they're being retracted to be able to have play on the pins for lowering and putting them in and out. I've now got to ream. I'm doing a final ream on the cutter itself. I'm running at about 220 RPM, and I have to take off about 2/10 of a millimetre, and I'm running in a feed of 0.0032 inches per revolution on that cut for this final cut. I've set up the device so that when it comes down it will clip it and remove it. So we'll just run this cut first and get through that. In between time I'll show you a couple of the jobs that have turned up today that I have to deal with, and some that have gone out the door, so they'll be subject to another movie. So we'll head over to the workshop bench first, past the 2 mills, off the boards. We'll swing around here over to the table, and we'll show you a couple of things. Oh, by the way, this is the post. This is the tube that gets screwed to the long tubes for the core cutting, and that's the window. I make these windows. I cut these windows out from these subs from time to time, and these are the actual doors that I make. The bent plate and cut and welded. These centerpieces are welded in, which is an improvement on the previous ones. I do a plug weld because the previous ones had a tapped thread in there and they were always getting lost. So normally when this is going down the hole, that door will be closed. When they retract the whole thing out of the hole and it's up on top of the rig, they take this off and then they'll clamp the core cutter on here, and with the hydraulic arrangement that I've made, the blade will then go through and cut the core. You can see there's the blade down inside. It'll cut the core, and then that blade will be left there, and I'm making another machine to be able to retract that blade out, because we've now found that the weight, the 27 feet or 9 meters of rock sitting above it, is too hard for them to remove this. So I'm going to make another item. I've ordered some jaws, some cutting tips for this head of mine. It's a Japanese head, and it's a very, very nice one. So I've only got this set in here at the moment. This is a geometrical die head, so I've ordered new dies and they should be here on Monday. Another job that came in is this hydraulic pump, and it has a stub shaft that fits on the shaft, and then there's 2 bearings that should run, one bearing here and one bearing there. They've had problems with this in the past, and they took it to some machinists and they knurled this part of the shaft, and of course that's failed. So now they want me to make a new shaft. It's hollow through the centre, and the reason that's hollow in the centre is so they can get a puller bar through to pull this out off the shaft. So this shaft, there's nothing I can do with this shaft. It's a hardened shaft. It's worn, so the best I can do is to clean it up, polish it up as best I can, and make as neat a tight fit as I can here. So I'm going to machine that up, then I'll have to cut the keyway, and then that's another job that'll be done. Other jobs went out today, and we're back over here to do that boring. Now another job that came in today is this reamer. Now this is a big reamer. This is a huge reamer. It's a tapered, over 2 inch, so 3 inch I think. They use these out in the field for reaming pins on big bulldozers and machines like that. And what they've done is they've cut the Morse taper that was here, and they've welded a nut on here, and they use this with a rattle gun, with a huge rattle gun. They do the reaming on site. Now of course they do damage, and as you probably can see here, if we can get closer, these some of these have been chipped and broken. Just a sec. Yeah, that one there has been badly broken off. All the way along here is broken. So this is coming into the to be sharpened by the guy that does the sharpening, but he can't sharpen it because he can't get it centered. In this end here, they've got a center, but on the other end where they cut the shaft off, they cut the Morse taper shaft off, they've welded a nut in there, but there's no way that he can get a center to center it up onto his grinding machine to be able to grind the flutes. So my job now will be to provide him with a center point here, and that can come in a number of ways. I may machine the nut down and make a cap to go on it, to press fit a cap on there with a center. And the way I'll do that is I'll set it up center point in the chuck. I'll set up the steady here. I'll machine a clean area in this area, then transfer the steady to this end here, and very gently then with a carbide mills, I will try and mill a flat area in here first, because that's very rough, and then get a center point to it, and I'll be able to dial off this area here. It's not guaranteed. I'll be able to dial off the edges here as well. It's not guaranteed that that's going to work, because of being able to hold this end here. So there's a number of other options, but anyway, that's another job that has come in and needs to be done. So back over to the mill, and we will begin the milling of the reaming of this diameter. So now I'll just push it over. It'll engage the feed. At the same time I use kerosene. That's my preferred cutting fluid for aluminium. Now this is a trial with the GoPro. I'm not sure that it's going to work okay. I've done a small trial cut once I'd got it completely centered, and I know I'm on size now, so this is a basically first and final cut. I'm using a cemented carbide square shank cutter in the angle slot of the milling extender. The setup here is simple, just 2 parallels, 2 strap clamps, that's it. Simple setup. we've got our X and Y set at 0, 0. The Z doesn't matter. And now we're winding our way down. You can see some areas are cutting cleaner than others. This is because of the few stresses that have been introduced into these parts while we were making it all together, making it up. Up here you can see our unit winding down, and once it comes to this stop, it'll release the automatic feed. There we go. We should be happy with that. Well, this is Bruce signing off for the number 3 in regard to the core cutter.